On and all present here. Before I start, I want to address here something. I want to say something that I'm in the initial first year of my PhD, so I don't have much to present. But then also, as we know, fly ash is a problem, and management of fly ash is an urgent need. So I'm going to discuss something about that. So the excess burning of pulverized coal leads to excess generation of fly ash, which is a coal combustion residue. And as we know that coal-fired power generation is a principal energy source throughout the world. And if we talk about the two topmost generators of fly ash with low utilization rate, so India and China are the two topmost countries. These are the two forms of the states of the fly ash. First one is the aerosolized coal fly ash and second one is the stored fly ash. So basically fly ash is rich in heavy metals, and these heavy metals can endanger the ecology and environment both to a larger extent. So this pic is of NTPC Sipat Bilaspur, Chhattisgarh. The second one, the stored fly ash one. So when we talk about the consequences of aerosolized coal fly ash, deterioration of air quality, see the global declination of pollinators, birds who are nesting near the vicinity of power station, near the dikes where fly ash has been stored. Then there is a report which states that there is a depletion of ozone layer observed in upper stratospheric zone due to the abundance amount of iron present in it. Then plant physiological and metabolical activity has been altered, like stomatal behavior and growth and productivity, like that. Health hazardous effect has been observed, especially to those workers which are continuously exposed to that particular area. This is the case of Florida's toxic algal crisis that has been observed due to the addition of multifold component of aerosolized coal fly ash. So these are the monitoring or the measurement. These are the several ways through which we can monitor or measure the aerosolized fly ash. Challenges, when we talk about the challenges related to fly ash sustainability, then regulation compliance, high production with low utilization, as population is growing, so abruptly growing demand of the power supply, efficient capture and disposal, and global effort is needed. So complete utilization of fly ash is the need of the hour. For that, we need the update blending standards by BIS that has been not revised since 2000. And second, the transparency should be there, greater regulatory oversights, price control, and extensive research. When we talk about the extensive research, say there are certain applications of fly ash in agricultural aspect. Instead of the presence of the toxic heavy metals, there are other macro and micronutrients that are essential for plant growth and development. So we need to explore in that particular aspect, and I am going to work in that particular aspect, agricultural aspect of that fly ash. So, thank you.
Good afternoon, everyone. Myself, Ankur Gupta. I am basically working in sub-seasonal to seasonal forecasting at NCMRWF. This is an earlier work. In this, I will be showing the simulation of haze events using WRF-Chem. So this is a study of application of WRF-Chem and seeing how useful was that in simulating these haze events in Southeast Asia. So, fires are common processes in Southeast Asia. So these could include forest fires, wildfires, but also, as we know from our own country, like agricultural waste burning is a big contributor to that, and also the land clearing for palm cultivation and other kind of agricultural land is a common practice in this part of the world. So the impacts of fire are very large compared to what we usually attribute them to. For example, in 1997, which was an El Nino year, and dry conditions over the Southeast Asia maritime continents, the fires in Indonesia alone, that particular country alone, produces an estimates of roughly 15 to 35% of total global carbon emissions for that year. So it's a huge contributor for during some years. In this talk, I'll be studying mostly about event of fire in June 2013, and so this study is focused on Singapore, and in June 2013 we observed the haze events even much larger than 1997. So we tried to understand what were the causes and whether we can attribute them correctly. So we used WRF-Chem for this purpose. These are the usual schemes. It is solving the Euler equations in flux form, and Runge-Kutta time split numerical scheme was used. It was a 30 kilometer, not very high resolution, but reasonable enough, with 27 vertical levels, which are terrain following. And for the long wave radiations, the rapid radiative transfer model, Lugia scheme for short waves, NOAA land surface model, and the planetary boundary layer was used from a scheme from Yonsei University, and then the REL 3D cumulus scheme. It has convective transport, but more importantly for this study, it also has convective scavenging in that. This WRF-Chem was forced with 6-hourly forcing from NCEP final analysis. So more importantly, when using these transport models for these simulation of haze events, we need to characterize the emissions, and emission inventory is the biggest channel, as many of you already know. So in this case, we used mainly the background concentrations of OCBC, SO2 dust, and sea salt from GOCART, which is a global model, and it's initialized model and gives the profiles of these species along the atmospheric column. So that was the background, and on top of that we used the anthropogenic emissions from retro datasets, for which was based on the year 2000. And also we used a Yevik and Logan dataset for estimating the aerosols from biofuel and burning of agricultural residues. Beyond that, because our focus was to estimate the emissions and haze events attributed to, whether they can be attributed to the fire events in Indonesia and Southeast Asia, we used Brazilian biomass burning emission model. It was a very good model at that time. So it used a global inventory of biomass available, and then how much of that biomass will be burning during an event. And on top of that, the regular emission factors, which are vegetation specific, and in this model they used 17 vegetation types from IGBP. The fires were detected, the fire hotspots were detected from MODIS dataset, and based on that, the emissions emissions were estimated from the biomass burning. This is not a perfect model, as we can understand that the fires detected from the models will not be there during the cloudy times, and then the burned area is also constant. On top of that, if you really want to have a realistic simulation of aerosols from these fire events, you need a plume model, which is very difficult to implement in WRF-Chem. So those are so for a particular fire event you can use that, but when there are large number of fires and so many fires in a large domain, then it is difficult to implement that because of numerical computations also. After this dataset, there was a utility convert-emis, which converts this chemical species into something which is usable WRF-Chem. So we had this setup, and then we ran it for after the event. So the event was mostly on 19th of June. So these are the MODIS fire hotspots. We can see this. So this is Sumatra, this is Borneo, and this is Java. And before the peak event of hazy event in Singapore, the fire hotspots were concentrated on the island of Borneo. During the fire hotspots, during the hazy events, they were concentrated mostly on the Sumatra. and after that it lingers on mostly on Sumatra, but the fire hotspots can also be seen on Borneo as well. These are the emissions for different chemical species. They are standardized by their, they are normalized by their standard deviations, and we can see as we expect that the fire counts and then the emissions overall over the domain is showing a peak around beyond 15th of June, and then significantly dropping by 23rd of June. So these are the the earlier were the fire hotspots, and these are the spatial distribution of the emissions. So for example, these are the anthropogenic only emissions of carbon monoxide, and we can see they are peaking over the island of Java because it has the most population density. But when we come to the total carbon monoxide, we can see it appears for that entire period of study from 1st of 30th of June on this part of Sumatra, which is very close to Singapore and Malaysia. Similarly, BC, black carbon, there is a background high concentrations over Java, but also during particularly this 1st of June 2013, it's very near to the fire hotspots we saw in this slide. So this is some of the slides for verification slides. Very difficult to get the aerosols data in Singapore also during that time, and so we use some of the proxies for the hazy to see whether the Earthcam is simulating the haze events. So for example, in this case we are using the carbon monoxide from MOPIT near the surface. And we can see, so this is 16th to 18th of June, 19th to 20th, 21st, 22nd to 24th, and we can see that the peak high concentrations were observed during those two periods, and not so much during the pre-event and the post-events, but they, as we can see, they are again increased on 20th to 30th of June. Again, these are the model simulations of different species, again normalized in Singapore, and we can see that as we experienced the haze event was peaking around 19th and 20th, but our model was also suggesting that the peak of all different chemical species were also during that time. In this case, the top panel is similar from the last slide. The bottom panel is we can see the plume. These are the carbon monoxide concentrations near the surface, and we can see 19, 20, 21st around that time the maximum peak of carbon monoxide. This is a verification slide much beyond the event. So basically, when the Singapore government released the data for their PSI. PSI is an index of air pollution in which PM 2.5, PM 10 and other chemical species were taken account for, and we can see that this peak is in June near about 15th to 25th of June, and which is matching with what I was showing earlier for 7th and 20th of June, and peaking around 19th of June. So the model was able to capture, I mean, there is no data to verify whether the chemical species were captured correctly, but the proxy of, we are treating the chemical species as proxy for the hazy events, and for the hazy events we have data from in the form of PSI. So next we studied, because the black carbon are an important part of these forest fires, so how the variability of these different species impact the hazy events in Singapore, and also what are the uncertainties in several parameters in the WRF-Chem model. So for example, here I am showing the carbon monoxide at the surface level, and this is the column integrated values of carbon monoxide from 18th to 23rd of June, and these are the emissions of carbon monoxide which are input to the model. And these slides are the EOF of these chemical species. So we can see that the variability of plume, the plume which we can clearly see in the EOF1, which is explaining quite high percentage of the variability, more than 30%. And similarly in EOF and EOF3, less, but the plume dynamics can be seen. Certain interesting things regarding the different sign of the loadings of EOF can be seen. But what I would like to stress over here is that carbon monoxide, if you see the column integrated values, we can see the impact of the pollutions coming beyond the boundary layer and spreading. So the peak is not seen as much as in the surface rather than in the column integrated values. So we did some experiments, numerical experiments with the to quantify the uncertainties in the scavenging coefficients. So we changed the scavenging coefficients from 0 to all the way to 1. And the realistic values are 0.1 to 0.2, but we can see as you go from 0.0 to 0.1, there is a large impact, and then there is an incremental impact. So we use, this is a domain average black carbon loadings. So we can see that the scavenging coefficients have a huge impact, but let us concentrate on these range, the realistic range of 0.1 to 0.2. So during for that range, we did an EOF analysis for the model output from the numerical simulations experiments, and these are the differences of EOF 1, 2, and 3 from the earlier slides I was showing. So you can see that the differences are very less. But interestingly, the fractional variance explained by the EOF1 and EOF2 are increasing at the expense of the lower, the further EOFs. So more variability is concentrated on the first two EOFs. So if we see that even though the black carbon is having the scavenging coefficients are having a huge impact on the black carbon loadings over a domain average area, but the variability, it is not impacting the variability. So we tried to see the reasons. One of the reasons we found is that so this is the black carbon loading over the column, the spatial distribution of that, and for different scavenging coefficients from all the way from 0.1 to 0.1, 1 to 5, 0.15, and all the way to 1, the maximum. So we can see that the maximum impact of the scavenging coefficients are happening near the populated regions of Java and further downstream for the trade winds. So because the background concentrations are high over there, so the plume dynamics are not affected by these scavenging coefficients, even though the total domain average loadings of black carbon were affected. So which was kind of a useful finding, because in that case, the uncertainties in the model regarding the scavenging coefficients are not impacting the simulation of the black carbon and by extension the hazy events and the ability of the WRF-Chem to simulate those hazy events are not influenced by the uncertainties in the scavenging coefficient. So that was a interesting finding, so which stresses that the usability of this WRF-Chem for simulating this fire events.
Present my work in front of you. Okay, I will be talking about the considerable heterogeneity in the PM oxidative potential over East and West Asia, and I will be dealing with to determine the considerable humidity. I was focusing on mainly on the carbonaceous aerosols. So what were the carbonaceous aerosols are? They used to emit from the anthropogenic natural sources, and they used to enter the environment, and after entering the environment, there is a gas particle partitioning. A lot of atmospheric process takes place, and they, due to some of the semi-volatile organic compounds, they used to, in the gas phase, they interact with the other pollutants like ozone, NOx to form their derivative compounds. So with the derivatization, it is mainly assumed that the toxicity of those compounds were increased, and it was reported earlier also. So my target was to determine the health effects due to those aerosols. So I was focusing on the why are we focusing on the aerosols? Because these used to enter in our body mainly from respiration, either though our dermal and inhalation, or dermal and ingestion exposure also. But as we are continuously breathing, and the PM 2.5 used to enter mainly by the respiration process. So whatever the PM 2.5, they used to enter in the nasal cavity, and the further PM 2.510 used to enter in the remain in the nasal cavity. Further final compounds goes into the lungs, and the ultra fine particles has the ability to enter into a deep dive under the alveolar sac of our lung systems, and from there these kind of aerosols generally used to produce long-term and short-term health effects to human beings. So there are various mechanisms reported in literature which shows the health effects, which explains the health effects to humans. But I am focusing on ROS because reactive oxygen generation is the widely accepted mechanism, and it directly relates the whatever the health effects we are facing. It directly explains this mechanism. So what are reactive oxygen species? These are free oxygen radicals. These are short-lived, and they are naturally there are various kinds of radicals present. There are ROS species. Some are of radicals and some are of non-radicals. ROS is generally naturally present in our environment. They are present in atmosphere also with various during daytime and their night time they produce in the environment also. And is it working? Okay.
Pointer is not here on the screen.
Oh. So not yeah, it is not working. Fraction. These are my acknowledgements. My professor and entire geoscience division of PRL. And thanks.
You have shown that the pHs was most of the part of EC.
Yeah.
Okay.
Actually, I have shown that the
Should
ROS
be
is a
OC.
part of EC. I have not shown that raw pHs is a part of EC.
Okay.
But
ROS,
I can add that during my PhD, I worked on pHs and nitro pHs. At that time, I was working on gas particle partitioning. So whatever the fraction emitting from the primary source is mainly with the EC fraction. So
okay, but not the pH. Is it
pHs only.
pHs only.
Yeah, pHs and nitro pHs.
Okay.
Space Center. Actually, I'm just 4 months into the field, so I have not much experience. If I make any mistakes, can you help me? And by the way, like most of the things what I was planning to say was already covered by Vijay Kanwade sir, so I will be quickly moving through it. So I will be talking about the impact of contrasting air masses on ultrafine particle burst events over tropical coastal location Tumba in Trivandrum during pre-monsoon season. These parts were already covered by sir, so I will just skip through it. I am mostly concentrating on aerosol particle number size distribution, which is dependent on sourcing and transformation processes, which are highly heterogeneous in spatial and temporal domains. And sir has already explained why NPF study of NPF is really important. Tumba is a suburban tropical coastal location located at the southwestern tip of Peninsula, India. And the observations were carried out in pre-monsoon season for 2 weeks from 12th April 2023 to 27th April 2023. The figure shows how the land breeze, which brings the polluted air mass from urban area, is really different from the cleaner marine air mass that comes during sea breeze. Here you can see the hygroscopicity of polluted continental air mass is actually lower than for organic species is lower than the marine species, marine organics. So here there are 2 pathways for precursors to grow into larger particles, which is already covered by, so it's either gas to particle conversion or condensation growth. Condensation growth doesn't actually decrease the total number concentration of the aerosols. Coming to instrumentation, I have used scanning mobility particle sizer. We have already seen the video. It uses a radioactive source to charge the particles, and it is fed into a differential mobility analyzer, which will segregate the particles based on its size. Then it goes into condensation particle counter, which counts the number of segregated particles, number of particles in each size. I used aerosol chemical speciation monitor to measure the non-refractory mass concentration and chemical composition of aerosol.
Good afternoon to all. I'm going to present my talk on the topic the role of aerosol acidity in controlling ambient visibility at an urban location in the foothills of northwestern Himalaya. This study was conducted in Jammu, which is located in the foothills of northwestern Himalaya. So first of all, introduction. The little introduction that urban environments have high levels of anthropogenic emissions which contribute to the formation of secondary inorganic aerosols through complex atmospheric chemical reactions. The acidity and liquid water content of these aerosols are crucial in understanding atmospheric chemistry and climate-related processes. Aerosol acidity has a significant effect on secondary aerosol formation through the gas to aerosol partitioning of semi-volatile and volatile species. Water uptake by dry particles, particularly composed of inorganic salts, take place at a critical relative humidity that is known as deliquescence relative humidity. As the relative humidity increases, the hygroscopic growth of particles will continue and become even much faster when relative humidity exceeds 80%. Once the relative humidity reaches the critical supersaturation ratio of aerosol particles, aerosols are activated into cloud droplets. So this property of aerosols to uptake water exerts an influence on aerosol optical properties, leading to increased extinction coefficient and impaired atmospheric visibility. They can changing the planetary albedo, aerosol optical depth, and the direct climatic effects of aerosols. And this studies particularly on impaired atmospheric visibility. So motivation of this work was to understand the governing factors for the reduced wintertime visibility in the northwestern Indo-Gangetic plain. The objective was to investigate the role of secondary inorganic aerosols and meteorological variables in controlling the ambient visibility. This is the methodology, this is the sampling site where we have done a comprehensive PM 2.5 sampling, and then we have analyzed those PM 2.5 samples for secondary inorganic aerosols like sulfate, nitrate and ammonium on ion chromatography, and then the properties of the aerosols were...
Has any question?
Yes, I have.
Yeah, please.
So, like you said that hygroscopic growth is also accelerating the scattering and absorption coefficient both efficiencies.
Yes, sir.
Like how is it? I didn't get this part, because what I think water only scatters more. So hygroscopic growth will be there, it will scatter more light. So, but you said absorption will also be there. So I'm a bit confused.
Yes, I will like absorption. If there are absorbing aerosols, they can absorb also.
But if there are hygroscopic growth is there, it means that particle
They
has
are
been
only
covered
scattering.
by. Yeah, that's.
You meant to say they are only scattering.
No, I just don't mean to say anything. I'm just curious, like how are they absorbing? Because you said the particle is there, but the hygroscopic growth will be there. So the water will be surrounding it.
Yes,
Okay, so scattering will be more. How can it absorbs?
There can be water soluble organic compounds which have that absorption efficiency higher as well. So that can increase.
So it's not only about the hygroscopic growth of the water, it depends on the constituents of the hygroscopic growth.
Yes, yes.
That is what I was asking. So, you have some chemical measurements also? Or?
Ma'am, we only did ammonium for this secondary inorganic
Chemical
aerosols.
composition measurements will help.
Because with the
For
secondary
this,
organic
because
aerosols,
the
WFO
input data for EM, it takes only ammonium, sulfate and nitrate as the basic inorganic salts in this.
Yeah, thanks.
My name is Garima
Hello. So my name is Garima Shukla. I am a research scholar at CSR National Institute of Oceanography, Goa. The topic of my presentation is the seasonal variability in fine particulate matter water content and the estimated pH over coastal region in the Northeast Arabian Sea. So in our study we are majorly focusing over the marine aerosols and the sea salt aerosol is the major constituents of the coastal region and the marine region aerosols, and the continental outflow is also impacting the chemical composition of the marine aerosols. So the aerosols is majorly its chemical composition is important, and the chemical composition we can see in this figure from where what is the sources of the aerosol. Like we can see in this figure, the sea spray aerosol is majorly comprising of the sodium and chloride particles, whereas the dust particle is majorly comprises of the carbonate and silicate particles, and the aerosols which is arising from the biomass burning is majorly comprises of the carboxylic and bicarboxylic acids. And the sulfate organic is majorly composed of the sulfate aerosols, ammonium and nitrate. So the source is the most important thing from where the aerosols is emitting, and it can vary on a pH scale from 1 to 8. So the objective of my research work is to quantify and assess variability of aerosol pH and liquid water content over the coastal region of the Arabian Sea using a thermodynamic model. So the study area is the Goa region. The reason behind choosing this study area, the Indian Ocean is having a unique kind of monsoon system, that is rotating monsoon, where seasonal reversal of winds is occur. As we can see in the southwest monsoon time, which is occurring during June to August, the wind parcel is coming from the oceanic region to the continental region and carrying lots of sea salt aerosols toward the continental region. As we can see in the northeast monsoon, which is occurring during the November to February, the wind parcel is majorly coming from the continental region to oceanic region and carrying anthropogenic aerosols to the oceanic region. So Goa is the region where we can see the influence of from both southwest monsoon and northeast monsoon season. That's why I chose this study area for our work. So this is the data set which I am using for the analysis. We are measuring the inorganic ions which is sampled at the CSR NIU Goa using high volume sampler, and we are analyzing them with the ion.
Good evening everyone. I am Valasani Srilekha from IIT Kharagpur. Today I would like to present on a review on haze and polluted fog episodes over Indo-Gangetic Plain. So these are the contents which I am going to discuss. Coming to the introduction, we all know aerosols are the tiny solid or liquid particles that remain suspended in a gaseous medium, whose size ranges from few nanometers to 100 micrometers. One of the major climatic impact of aerosols is visibility reduction, which is due to absorption and scattering of light by both gases and particles present in the atmosphere. Based on the composition of particles and the intensity of visibility reduction, different phenomena exist like haze, fog, mist, dust and smoke. Of this, haze can be defined as a phenomenon in which visibility is reduced to less than 10 kilometers due to the accumulation of tiny particles of dust, smoke, salt and other suspended particles, while fog is a phenomenon where the visibility is reduced to less than 1 kilometer due to suspension of water droplets. In clean atmosphere, fog consists of only water droplets, but in polluted atmosphere, it consists of pollutants along with the fog droplets. So herein we will be using the word called polluted fog. Coming to the motivation of study, it is observed that often IGP is engulfed in thick haze and fog episodes, which is constituted of high concentration of PM 2.5, much higher than the level which WHO deems healthy. You can see it is one of the example where there was an event occurred from 30 to 9 November. On 7th November 2016, visibility was as low as 300 meters and the daily mean PM 2.5 concentration was 793 microgram per meter cube, which was nearly 13 times higher than the national ambient air quality standard. Also, people upon exposure to such high PM 2.5 can develop symptoms like breathlessness, chest constriction, allergy, irritation in eyes, etc. These can also impact the climate by altering the cloud properties and the lifetimes over the polluted region. Sulfates and nitrate aerosols increase the acidity through the deposition as well. It can also cause economic losses to the country by closure of the schools, offices, industries, etc. and also impediment of the road, railway and airport transportation, also by the tourism. Government has come up with some of the technologies like odd even vehicle rule, CNG buses, anti-smoke guns and the gigantic smoke towers, but the results were not that efficient. So everyone must be knowing, or there is a need to get an answer why PM 2.5 is increasing and what is the potential governing mechanism for it during haze and the polluted fog episodes. What are the characteristics and the composition of haze and polluted fog episodes? These are the gas phase oxidation reactions and aqueous phase reactions. And these are the possible reactions of the secondary organic aerosols. So the thing which we can analyze from here is haze and polluted fog is a combined influence of regional transport, meteorology, local emissions and topography. So the factors influencing the formation of secondary species such as the level of precursors or oxidants, characteristics of the pre-existing aerosols and meteorologic conditions all are varying by location and results in different formation mechanism in different areas. So there is a high need to do modeling studies as well, where we can get an interrelationship between the meteorology, climate, chemistry, transport, local emissions, regional transport, and also through modeling one can be able to analyze the spatial and temporal distribution of pollutants over a wide region. Then one can get a relation between the emission changes from different sources and the resulting change in the pollutant concentration. Also the long-term simulations for emission control scenario can be done through modeling. So overall I wanted to conclude saying that the classification based on PM 2.5 visibility and RH would be more useful in identifying the haze, fog and the transition of the things, and a proper statistical analysis need to be done to come up with the thresholds. And limited studies of physico-chemical characterization of PM 2.5 are done, especially in other parts of IGP, so there is an urgent requirement of high real-time measurements. Although organics are high in concentration during haze and polluted fog conditions, organics rate of increase is higher during haze, but water-soluble inorganic ions rate is higher than OC during the polluted fog conditions. Analysis regarding formation mechanism and source apportionment of sulfates, nitrates and ammonium in Indian conditions are urgently required, and the factors influencing the formation of secondary species can be come up with more modeling studies are required, that too particularly chemistry, chemical transport modeling studies, where one can analyze the relationship between the components and to know how much concentration is required for to reduce the intensity of PM 2.5 over region, so which emissions needs to be controlled. This one will be able to answer only through modeling, so further modeling studies are required. These are the references. Thank you.
Hello everyone, I am Yash Daima from Ahmedabad University, Gujarat. The title of my presentation is Assessing the Indoor Air Quality in Diverse Microenvironments at a University Campus. Professor Adit Vaishya is my advisor. Just some basic motivation behind doing air quality studies. So, in December 1952, there was a fog event in London. People just thought that it would be a simple fog event, but it was found in the air. There were a lot of toxic pollutants were found, and there was a lot of causality during this event. From then, people started recognizing the importance of air quality studies. These are the contents of my presentation: introduction, objectives, then instrumentation, methodology, results, conclusion and references. We all know about the basic terminologies. I will just go fast through it. We all know what is air pollution and what is PM. These are some of the different sources of air pollution, sources of outdoor air pollution and indoor air pollution. So, Health Effect Institute in United States of America, they prepared one report, State of Global Air 2020. So, this graph came out of that report. This is the ranking of worldwide death reasons due to different components, and we can see that air pollution ranks 4th in the death reasons. Then if we talk about India, then what is the impact of different pollutants on number of deaths? So we can see that over the years, the deaths due to the ozone are like increasing little bit. Then deaths due to solid fuels from household air pollution. There we can see there is a decrease in those deaths with time. Because before we were used to mostly use wood burning, but now there are more cleaner technologies like LPG, etc. They are available, so those deaths are decreasing. But the alarming sign is this PM2.5. We can see that from the graph that deaths due to PM2.5 air pollution are increasing over time. So it is very important to study, very important to increase the measurements and analysis of PM2.5 concentration over different regions. The objectives of this study are, first question I'm trying to address is how much particulate air pollution is there in different microenvironments more away. It is more away from the outdoor air, so it is like little bit more, 10 minutes more. Then for this location, this is I am saying that confined outdoor. So it was an indoor location only, but it was confined, so I gave it name confined outdoor location. Here also we can see that lake time is very less. It is around 10 minutes only, because it was mainly impacted by outdoor air, and there were no active emission sources there. Then in the So this is the last one. For the mechanical workshop, we can see that this lake time is coming around to be 80 to 90 minutes only. But we should notice one interesting thing here. The correlation coefficient is less here. It is not high, just like here it is around 0.9, 0.9, 0.9. But here we can see that this correlation coefficient is coming down. What could be the explanation for this? Here in mechanical workshop, there are emission sources. So it is obvious that the correlation between the this indoor air PM2.5 concentration and outdoor concentration would not be that much great. So that's why it is down. This is just simple, the outdoor one only. So what could be the different conclusions from this? Highest concentration is found at the locations where the sources such as cooking emissions, cutting, assembling activities are present. And cafeteria, this 24-hour average PM2.5 concentration was approximately twice than NEC's guidelines and order of magnitude higher than WHO guidelines. Most probably due to the cafeteria and the mechanical workshop, welding, cutting, bending, the different activities at workshop and emission activities at cafeteria. This lake correlation analysis suggests that good correlation exists when between this ambient PM2.5 concentration and indoor PM2.5 concentration, where almost no sources are present. But the locations where active emission sources were present, it was poorly correlated with ambient air pollution. So it indicates that cooking it is dominant factor in the modulating air quality of cafeteria. Source control measures such as proper ventilation hoods, maintaining proper combustion gas stoves, etc. Can be used to decrease the indoor air pollution. These are the references. Thank you so much. Yes.
The parking basement also act as a source now. Like when you park vehicles, it will have an exhaust. Okay.
Yes.
So whatever is coming from automobiles, it will also have it will also act as a source. But these cannot be reflected. Like in mechanical workshop, you said that correlation is very less.
Yes.
And the lag time is more.
Right.
So for the parking basement, the correlation is good and the lag time is very less.
Very nice observation, and it is very interesting question. I have not exact answer to this, but I know why it is probably why is it probably. Actually, exhaust was working very good in those parking ones. So and the cleaning activities were also frequently made. So I think due to that the PM2.5 concentration could be very quickly removed from that environment. That I think it is the reason.
Do you have parking in the basements?
Yes, in the basement.
Consider that, because air flows on the top. It will not go frequently in the basements. So I think whatever the source is it's because of the vehicle exhaust only.
Yes, sources
Not the
are,
outside.
yeah. But I think that the exhaust is working very fine in that, not about vehicle exhaust, the exhaust fans.
No,
like
I'm
that-
talking
that
about
exhaust.
the motor exhaust, like whatever the fuel is burning for the motor vehicles, whatever is coming out,
Mm.
if the parking is under the basement, so it's my probable thinking that whatever is outdoor pollution is there, it might be not the cause for the basement parking zone.
Oh.
So that might be itself like you got my point.
Yeah, yeah, got it.
So
Got it.
that
The outdoor, the effect of outdoor, how much could be there, that I need to think.
Yes.
Yeah. Thanks, I will think about this.
Thanks.
Thank you, Yash. Now, Sharma from Central University, Jammu. I am working under the supervision of Dr. Shweta Yadav. Today, I will present my work titled Understanding Carbonaceous Aerosol Dynamics in Jammu region of Northwestern Himalayas. First of all, I don't think it will be necessary to define aerosol as it has been nicely defined by other presenters before me. So I'll quickly jump to carbonaceous aerosols as they form a notable fraction of total level of PM2.5. Many studies have concluded or have defined that CAs or carbonaceous aerosols, they constitute about 20 to 50% of the chemical composition of the fine particulate matter, that is PM2.5. And also they are very important to study because they impose critical impacts on air quality, human health, climate processes, and also the Earth's energy balance. So, owing to their significant impacts on multiple regimes of life, they form a prerequisite aspect of research whenever an atmospheric study is attempted to be initiated. Also, CAs chiefly include organic carbon and elemental carbon. Organic carbon is considered to be emitted through two main pathways. First one is directly from natural or anthropogenic sources, and that is considered to be as POC or primary carbon, organic carbon. And second one is indirect entrance through atmospheric reactions by gas to particle conversion, which is considered as SOC or secondary organic carbon. EC, it is considered to be mostly released after partial burning of coal, vehicular fuel or biomass, and it is mostly considered as primary pollutant. Significant EC and OC contribution, they are known to be emitted from China and India, with India being the most greatest OC emitter. And also the eco-sensitive zone of northwestern Himalayas has witnessed significant emissions from anthropogenic sources in past few years. So that's why it is leading to challenging deterioration of air quality there. And Jammu city, as it is located in the foothills of NWH or northwestern Himalayas, it has been also designated as a non-attainment city, where the particle load is beyond the safe thresholds as set by NACS, by CPCB. Therefore, aerosol identification in this eco-sensitive and fragile location, it becomes very necessary for estimation of particulate pollution, source characterization, and associated health concerns to local population in addition to environmental repercussions. The main objective of this study is to understand carbonaceous aerosol dynamics over Jammu region. For achieving this objective, analyzed using this technique. This showed at background site main contributors were biomass burning, vehicular emissions, and gasoline vehicles and cooking, which basically F1 contributed towards 24.17 to total carbon emission, and then factor 2 contributed to 20.97. At industrial sites, gasoline and diesel exhaust contributed 24.93%. Mixed vehicular exhaust and coal combustion contributed to 16.79%, whereas at curbside, factor 1, which is emissions from cooking and vehicles, they contributed about 14.21%, biomass burning and vehicular exhaust and gasoline vehicle emissions, they contributed to 10.52 and 13.44% of TC. At commercial sites, we observed that vehicular emissions and biomass burning, they contributed about 20.74%. Diesel vehicle emissions, they contributed 8.37%, whereas coal combustion emissions and road dust, they contributed about 8.05% to TC. And at last, at residential sites, the main sources were found to be as biomass burning and gasoline exhaust, emissions from gasoline vehicles and kitchen smoke, and also diesel-driven vehicular emissions, which further contributed 20.63, 14.76 and 7.47 respectively. So for conclusion, we can understand that the result from this present study, they have ascertained that at all the sampling locations, the yearly average concentration of PM2.5 aerosol mass load, they were below the NAC's limit of 60 microgram per meter cube, but they were well above the WHO norm of 15 microgram per meter cube. And also the curbside site, which is, as I mentioned, that it is joined by a longest highway in India. It has the highest levels of PM2.5, OC, EC and TC, which can be traced back to emissions from vehicles as it is adjoined by, again, this highway, especially diesel trucks with some emissions also coming from nearby cooking smoke as well. Increased biomass burning for heating purposes and an increase in the number of pilgrims who drive to holy temples, especially during the months of winter, they cause the 24 average concentration of PM2.5, OC, EC and TC to rise above this NAC's limit at all the sampling sites. On average, the total carbonaceous aerosol proportion is around 30% in total mass of PM2.5 across the study period over the study area. These results also show that as SOC is also a significant contributor to total carbon, at CUJ, BBN, CUJ is actually a background site, and industrial site is BBN, and KCN is a residential site. And in the overall region of Jammu, it is contributing to about 53%.